Hi, for this video what we're going to do is we're going to solve a rational inequality. And a rational inequality is looking for all values of x that yield the result where our values are less than 0. So with this, what we're doing is we're looking for all values essentially that are negative because we have less than 0. So what we want to do is we want to set both the numerator and the denominator equal to 0. We're going to start with the denominator equal to 0, and this will give us our asymptote. So at this point, if you were graphing this, the f of x function is equal to this, you would have asymptotes when the denominator is 0. And it cannot equal these values. So the denominator can never equal 0. We know that it cannot equal 0, so we would just solve the equation x squared minus 9 equals 0. And with this, you can either factor here and say that this is x plus 3 times x minus 3 equals 0. So you would have x equals negative 3 or x equals positive 3. Or you could have also, at this point, just set it x squared equals 9, and then you have to take the square root, and remember when you take the square root and you're solving a quadratic equation that you have to remember to put both the plus or minus 3. So that tells us that at the points 3, it can include this, and also at negative 3. At both of those points, if we were to graph this, we would say that, those points are excluded because if I plugged in 3 or negative 3, I would have 0 in the denominator, which is undefined. We also need to set the numerator equal to 0, and because we're looking for all values that are less than 0, we would also not include this one. So we would just do the x minus 5 squared equal to 0. And with this, if you square root 0, you're just left with the x minus 5 equals 0. So x cannot equal 5 either. So if we went over 2 more places, we would say that x cannot equal 5. So what we're going to do is we're looking for the sign. Remember that we're looking for the sign to be negative. So I just use a table to help me so that you can see what I'm doing, so you can see where I'm getting the numbers from. You don't have to write this down. You could just talk about what's going on and what the signs are. So for this, we would have x minus 5 squared over x squared minus 9. And then we want to see what the sign is. And we're looking for negatives are what is going to make this true. So the first value that I'm going to pick is going to be in this interval right here from negative infinity up to negative 3. So I can pick any value that is to the left of negative 3. So I'm going to pick negative 4 for my first value. I'm going to then plug that into here. So I would have a negative minus a negative gives me a negative squared. And in the denominator, negative 4 squared gives me, so with this, negative 4 squared would be positive 16, and 16 minus 9 would give me a positive. So since I have a positive divided by a positive, we would end up with a positive, because remember that a negative squared is really just a positive, so we would end up with a positive sign here. So that's not part of my solution because we're looking for values that are less than 0. So then we would go to the next interval. So the next interval is between negative 3 and 3. So I'm just going to pick 0 because that's the easiest one to work with. If I plug in 0, I really have negative 5 squared, which is a positive, divided by a negative, because 0 minus 9 is also negative, so I would get a negative here. So all of these values in between here would give me a negative. So that's part of my solution. We would go to the next value or the next interval, so we need to pick something between 3 and 5. So I'm just going to pick positive 4. And positive 4, again, we're going to have a negative squared, which is going to give me a positive. And 16 minus 9, again, if I were to simplify this, this would give me a positive. So a negative divided by a positive is a positive. So this one is also positive here. And then the last one is numbers that are greater than 5. So at 5, it can either touch it here, or it can be at some point it's going to touch it here, and we're going to see what happens, whether it touches it and it goes down below or whether it stays above. So with this, the last value that I'm going to pick is 6, and if I plug in 6, I have a positive divided by a positive, because 36 minus 9 is also positive, which gives me a positive. So this also would not work. So the only place that works is from -3 to 3. So if you're writing this in interval notation, it would go from -3 to 3 would be my first answer, and it does not include it because of the fact that we are only looking for values that are less than 0. If it was less than or equal to, we would put a bracket around both of those. Set notation, we would just use x such that x is greater than -3 but less than +3. So it's in between -3 and 3, but it does not include those values. So with this, like I said, sometimes it is helpful to see the rational function, what it would look like graphically. And so we could plug this into either a graphing calculator, or you could plug it into something like Desmos.com, which is what I'm going to use right now. So I'm going to just plug this in. I'm going to do x minus 5 squared, and then we would do divided by, and we would just put this in parentheses as well. We would do x squared minus 9. So you can see from this graph here that it does a really weird curve here, so that's why it does end up being positive. It touches it and then goes back up. So we can see that only in this part right here do we end up with negative values. If you wanted to see the asymptotes, you could add those in there so that you can see that it's from -3. So I could just put this in as x equals -3, and I could also put in x equals +3, just so that you can see, sorry, I just need to put in 3. So x equals 3, you can see that this is in between those values. It looks like it touches, but it really gets closer and closer and closer to, but it doesn't touch. So you can see visually that our answer makes sense. This is the only part of the graph of the function that is actually negative. As always, thanks for watching. If you have any questions or there are topics that you need me to cover, please just let me know.